This is the presentation for CS683 project checkpoint 2. Our topic is page size aware cache prefetching. Problem statement: we know that existing spatial prefetcher are restricted to 4 KB boundaries because that guarantees the physical address contiguity. The problem is that nowadays modern system frequently uses large pages like 2 MB and 1 GB. So because of 4 KB boundary, we miss the opportunity for timeliness and coverage. What is the challenge to implement dynamic page size support is that the lower level cache don't have the information of the page size information, so they need to get the access of TLB and then do reverse address translation, which will uh, increase the latency and energy overhead, which we don't want. There has been no prior work for this dynamic prefetching. What is the goal to achieve the dynamic prefetching? That we need to make a page size propagation module which will propagate the page size information to the lower level cache. By using that information, we need to design adaptive logic which will select which will select the appropriate prefetcher depending on the page size, whether it is 4 KB or 2 MB. This is the diagram to show how the page size propagation module page size will get propagated. So whenever there will be a miss from L1D, the page size information will flow to L1D MSHR, which will tell that was the size of page. 0 means 4 KB, 1 means 1 MB. Now we have used some prefetchers like SPP, BOP, PPF and VLDP. We used traces specified by the paper like 410 B waves and 470 LBM. So which these different traces covers diverse memory behavior, streaming, pointer caching, etc. We need to implement 2 MB page size support. The issue is that the paper does not specify where and how the page size information is generated. It does mention that the 85% of memory uses 2 MB pages for the given traces. We tried to randomly allocate 85% of pages to 2 MB and rest to the 45 KB as dynamic page selection. We were able to propagate page size information partially through MSHR. We were able to run prefetcher and traces mentioned in the paper correctly in 4 KB and 2 MB alone. So here is the implementation of the SPP prefetcher in 4 KB page size, where we can see that the allocated pages are nearly 11,930, and when we just made it support only 2 MB, we can see that for running prefetcher SPP for 2 MB support for the traces 470 LBM, we can see that the page size is 2048 KB, which means 2 MB. Also we can check here that now allocated pages are 34, which proves that it is supporting for 2 MB pages throughout the traces. Now the problem we discovered that we were not able to implement the dynamic support like 4 KB and 2 MB both. Later after interacting with author, we get to know that author used a private modified version of ChamSim which is not publicly available. Author mentioned that he used a modified trace where the traces itself contained the page size information. Author also suggested us to try a different ratio of page allotment and decide which ratio is best, and we were kind of doing that already. The paper does not document at all that what are the changes we need to do for modifying the ChamSim, like what page mapping we need to do, how the TLB structure should be changed, and how the page walk should be changed. We tried to change the VA to PA translation in the main.cc, but even though after doing these changes, when we when we ran the simulator again, the code was compiling, but the problem is that we faced uh, the page were still allocating either only to 4 KB. It was not dynamically allocating. We tried to debug that, and we get to know that this VA to PA translation is also called in many places, and we because of the structure of the ChamSim, we were unable to debug that. Translation, that functions of VAPA where it was called. So that's why we were not able to achieve the target which we promised. We tried we tried author's strategy, and we also consulted with TH, and tried to do the changes, but still we were not able to achieve the uh, our goal. But we do under tried but we in the process we do understand how the ChamSim's internally architecture is, and we learned how the page walk is implemented in our ChamSim and all. Thank you.